Hola? Okay, perfect. That's the only word I know in Spain. Okay, maybe also adios. And I hope this image that I created with AI is not lying to me, that there's something that is not related to Madrid in there. But if that's the case, of course, it's not my fault. It's the fault of the AI. So yeah, since Daniel talked a bit about the problems, maybe, with AI, today I want to talk a bit about the practical way how we can use AI. And my main take is in general just that what is good for developers is also good for agents. And yeah, if you want to scan this, these are my slides, then you don't have to make any notes, nothing. There are so many additional references, like some other blog posts, because yeah, I could talk for hours about AI. And also, yeah, we have enough time by the end for questions, so if something is unclear for you, make a note, and then after my presentation, I'm happy to answer that. Or also, I think that's why we are here, that after, or at the after party, just find me, ask questions. I think this is, for me, always the most fun in conferences. So who am I? Quickly, my name is Opalic. I always tried to find projects where they used Vue. I managed that now for more than 8 years. I'm a developer at Auto Payments. I live in Bavaria, near Munich, and I have a blog where alexop.dev, where I started to write about Vue and TypeScript, and lately also more about AI. And yeah, last year I started with being a speaker, which is really awesome. I can recommend that, and the Vue, everyone from the Vue speakers, they are awesome. So I don't know who of you ever saw this image. Maybe raise your hand. It's from a blog post from Dan Shapiro, where he basically explains the level of AI-assisted software development. So at the beginning, we had the spicy autocomplete with Copilot. I think this was the first introduction to AI. And then Cursor came, where they introduced agents, which worked even better. And you see here maybe the software factory, the idea is that you can automate everything. I think this doesn't work at the moment. I myself see myself more at level 3, where the agent is writing most of the code, but I spend the time and review everything and read the code. And sometimes, I also, be honest, I feel a bit like a bottleneck there. But yeah, level 4 is for side projects, yeah. But I would, at the moment, I would not recommend to go level 4 or level 5 with the current status we have. And also what I found crazy is, I don't know, 2 weeks ago, the creator of Bun started to use AI and Cloud Code to rewrite Bun from SIG to Rust, and he also merged it, so it's not officially yet, but if you follow his tweets, I think there's a high chance that soon Bun will be written in Rust, and most of the code then was written by an AI. So my take is you don't have to write code anymore, but I also think it's only half true. I think this only works if 2 things are true. First, you as a developer are experienced with the tech stack, so I would not use AI to let it run Rust because I have no idea what good Rust code is. And also the code base needs to be written in a way that it's easy for an agent to work with. Because, yeah, it's clear if you have a greenfield project, everything works with AI, but for brownfield, if it has no tests, if it has components that are 10,000 lines long, it can be a mess if you don't clean it up first. And what we talk today is first what an agent actually is. Then also we talk about context, what are feedback loops, discoverability, and where I think the whole thing is heading. So what is actually an agent. I don't know if any one of you ever has built his own coding agent from scratch, something like Cloud Code or Codex. If you have, okay, one person. So one tip that I can recommend, if you want to get better with AI, build your own coding agent. Then you understand what tools are, you understand what a loop is, and then it's not magic anymore. And then you get a better feeling why AI sometimes is doing things correctly and why not. So in short, an agent is running in a loop. You have the large language model, and if you build something like Cloud Code or Codex, you need to give the agent tools that he can read the file, that he can write something, that he can do grep. So a tool, this is the type of a tool. You have a description and a schema, and then a function. And the only thing that the large language model is seeing is the description and the schema. And then for a simple coding agent, you can have a map, and then if you read, edit, and bash tool, of course, bash is the most powerful, and then you have a function. And my little coding agent, I was using bun, and this is what the agent then can execute. So important, the model only sees the description of the tools. And since the models are also trained in that way, this is enough for the agent to know when you say, write a test, that it knows it needs to use the read tool, needs to maybe use the edit tool. The only thing that we need to do is to give him the correct tools. And yeah, a loop is then just a recursion. So first we make an API call where we give the messages, the system prompt, and the tools that exist. Then maybe the agent wants to run a tool. If he doesn't run any tool, then we just return. Then we wait for the user to do something else. If the agent needs to run a tool, then we start the loop again. And yeah, messages is just an array. So here, simplified, you have maybe only two roles, the user and the assistant. And then the array is just a string or a content block or a tool result block. And this is every time what happens. If you open Cloud Code, you do something, it will fill up kind of the array. And yeah, I created that, I don't know, 4 months ago. I called it nanocode. It's not working perfectly. There's still many things you need to optimize. But this helped me to understand in general what a coding agent is. So yeah, my main take again, clean code is not nice to have anymore. I was in many projects where people were telling me we don't have time to write tests, all these things, and I think now you need to have a really good code base. Otherwise, it will be a mess with AI. So what is context? So this agents MD, who knows what agents MD is maybe? Okay, I would say around half of the people. So agents MD is the first thing we can optimize. Who knows this movie from Christopher Nolan? Okay, if you know this movie, then you kind of understand the problem of the agents. So every time you open a new chat, the agent is not like a real developer who knows the project more than 2 or 3 years. It needs to use the tools, and then it gets all the knowledge into its context. And then it knows, okay, this is a Vue project, this is a Nux project. Of course, every model has a context window, like our array, and it works best when it's not full. So in the beginning, if you start a new chat, there is already something there. There is like a system prompt or our tool definitions. System prompt is often from the provider where they say you are a helpful coding assistant, something like that. And if you use /context, this works for Cloud Code, I think also for VS Code Copilot, you see the context that is already spent. And there, it's a new chat, that's why there's still enough tokens left. But you see here, these are the tools that exist. The agents MD or Cloud MD file is also included. Maybe skills, custom agent, system prompt. All these things are there. And the more things you do, the more the context is growing. And there's a time where the context is full, and what something like Cloud Code is then doing is is compacting everything. So that's why AgentsMD, CloudMD, this is what we can do in our project to give the agents a bit more help. So he understands this is a Vue project or it is a Nuxt project. And the thing that you should not do is that you put everything into the bad part. Because the problem is that this will be included into your context every time. And if you have an AgentsMD file that has, I don't know, 80,000 K of tokens, then you cannot do anything else anymore. So that's why a better approach in general is you have here a reference. So here you can describe, I don't know, use PN, what the project is. But if you want to explain how your testing strategy is, or in this example, Nuxt content gotchas, you write it in an external Markdown file. And the agent is then clever enough, if he maybe needs to write a new test, that he will load this testing strategy automatically. So this is called progressive disclosure. So we only give the agent the context that it needs at the right time. Okay, now forget looks maxing, or maybe also sleep maxing. Let's talk about brain maxing. So I found brain maxing is an interesting project from a developer from Cursor, where she kind of has a framework how to give an agent documentation. So there is this brain, there are some skills, there are also some hooks, and you can use this idea, and then you can customize it for your project. And what is the idea? The idea is that there is one index.md file. And there with wiki links, we describe all the documentation that exists. And then the brain itself is just a folder with Markdown files. Because people found out that you don't need RAG, you don't need something complex. Most of the time, the most simplest approach works best. In this case, is wiki links and Markdown files, and then agent has a memory. So who of you knows what skills are related to AI? Okay, around half of the crowd. Yeah, in short, it's kind of like a prompt, but also a Markdown file. But the agent is getting the name and description when you start Cloud Code always into its context. And then he knows if you say, remember this, that it needs to load this Markdown file, and then you describe here in this case, review the conversation and persist learnings to brain. So this is useful if you do something with the agent, you find out, okay, he was using the wrong comment, you can just say, remember this, and then the agent will update its own memory. Yeah. And there are also something called hooks, and with hooks, the idea is, with Vue we have life cycles. We have on created, on mounted, and you also have life cycles when you use Cloud Code. So one life cycle is session start. And here, what we say is every time a new session starts, it should get the index.md file that we saw here automatically into its context. And then agent knows, okay, these are the things that exist. There's also another tool there. Every time you add a new folder here, there is a hook running that will automatically update the index.md file for you, which I also found interesting on this brain maxing framework. And there's much more life cycles. Maybe one life cycle that is interesting when the session ends. You could set up something that you get a WhatsApp message, or that, I don't know, you see a notification. So you can play with that, use hooks, do deterministic things. Could also do a hook to log every time the agent is running a tool. Or one hook is that you don't want the agent that it should read the .env file, for example. So you could forbid him to read the .env file. And yeah, this is kind of how brain maxing then works. We work with cloud. Then at the beginning, session ends, we can use the reflect skill. There's also a ruminate skill, which is interesting, because every time you use a coding agent, all the chats are stored somewhere on your file system. And you could say to the agent here, read the conversations and see what you did wrong and automatically update your brain. So the brain is then kind of documentation for the agent, but also useful for developers. This framework also has a plan and review skill in it. You can use that, but I'm not a fan of plan mode so much, but yeah. And also, there's one skill that you can maybe run once per week, which is checking if something in the brain is maybe outdated or if you can optimize something. Yeah, so with this idea, you have for your project memory. And yeah, these are the skills that exist. And also one thing that this project is shipping is something called principles, which are just in the end some markdown files. So you don't need to use them. You can read them, but one principle would be the boundary discipline, which basically means business logic should always be in pure functions, and the shell is thin and mechanical. And then every time you open Cloud Code, it's reading this 15 principles, and it has maybe a better taste how to write code. And you can also define your own principles. And also, Cloud Code itself also has something like that now built in. So sometimes it's saying, we're calling memory, and then it's automatically storing some markdown files somewhere. The problem only is that this only exists on your machine. That's why I like the idea of having this brain as part of Git itself, and then every developer has in the end the same memory. And also, one question or one problem that you always have, you want to use views, you want to use Next UI, but the agent doesn't know how to use it. The training data is not up to date. What you can do is give the agent views. What do I mean by that? You just clone views as a Git subtree, and then the agent itself has the whole source code always part in its context. You could do the same for Next UI, and then in the agents.md file you say here's views. When writing new composables, mirror the patterns in, and then it writes composables in the style of views, for example. Of course, what I would recommend is in VS Code, if you search for something, you don't want to read file from the repos that you cloned. And you could also then say to the agent that he's creating its own documentation that describes how the patterns and style are for views, which then maybe also save more time. So this sounds stupid, but once you try it out, it works really good. My experience is much better than, I don't know, using MCPs, skills. Yeah. So these were the things I think we can do to improve memory, and also that it works better with different libraries. And also one important thing that we need to have in project is feedback loops. So what is a feedback loop? Feedback loop is, your project should use TypeScript, because then you can run type checks, and you have a deterministic way to check if something works or if something doesn't work. Another feedback loop is OXLint, as we learned earlier, which is really nice, really fast, also for formatting. And yeah, if you use Vite+, they have a VP check command, which is executing type, lint, and format at the same time, which could also be helpful for the agent. Then agent is done with this task, and then he automatically runs VP check, and then he at last doesn't make some obvious mistakes. And also, I wrote once a blog post about my opinionated ESLint rules. Two rules that I really like is this max depth rule, because then you don't end up in projects where a component has, I don't know, 5,000 lines of code. I don't know, who of you ever was in a project where a component has, I don't know, 3,000 lines of code? Or, okay, yeah. And yeah, developers cannot read it, an agent can also not read it. And also max prop, of course, it doesn't need to be 6, but I think there should be a maximum number, how many props a component should get. And yeah, there are also much more useful ESLint rules. And you can also write your own custom rules for specific things. Yeah, of course, testing, but this always depends how your testing strategy should be. So unit tests, component tests. And yeah, there are much more layers. Also some way to automatically test accessibility, to check if dead code exists, all these things. And what I now do in new projects is I copy-paste my own blog post and tell to the agent here, please set up the project with the layers that make sense for my project. And with this, we have many, many feedback loops that run automatically. And also what I find interesting is to give the agent a tool that he can click on a browser itself. So there's the agent browser CLI from Versal. Who of you ever have used the agent browser CLI? Okay, so if you never have used it, the idea is you can install it, and then the agent, or with a CLI, can open localhost. He gets a snapshot, so he sees in a DOM tree the refs that exist, and then he can click somewhere. And this is then really useful, because what you then can do is, if you have a bug, you say to the agent, here, please, use the agent browser CLI and reproduce the bug. And once it can reproduce something, then it's also easy for the agent to fix the bug. But it's in the end the same that a good developer would do. Yeah. And the idea is agent starts the local app, then it runs, then it can use the agent browser, can click around, and he then gets feedback, and he has his own loop. And also, what I can recommend something like Husky or Left Hook, where for each commit, you run linting, type check, and everything. Now for the last part that I think it's worth to improve, discoverability. So most Vue apps start flat. So if you create a new Vue application now, you get something like this here. You get a components folder, you get a composables folder, stores, views, router, and of course the problem is for real applications over time, this components folder will be really huge. And it will be hard for any developer if he only needs to change something on a checkout to know which components and composables are related to that feature. So flat works good for small projects, but yeah, it breaks once the application gets bigger. And the idea of feature sliced or modular monolith tries to group the things not on a technical level, but more on a domain layer. So here, imagine we have a workout tracking app. We start with a flat approach. We have workout active mode, workout header. Everything is under components, composables, and stores. Then the first thing we would do is we would find out what the domains are. So we have maybe a workout domain. We have a timers domain, exercise, and a settings domain. And once we have that, so this is always the hardest part, especially on a bigger code base, to really understand how your domain is. But once we have that, we can now put everything under features, and then we have workout, timers, exercise, and settings. And there itself, everything is then written in a flat way. And now, if I need to change something on the settings page, yeah, I don't care about exercises, timers. I can just go to this folder, and I see all the files that exist automatically. And also, the agent has the same problem as us. So the agent, as we know, can use tools like grep and bash. And if he knows that under workout all the features are, then it's much easier for him to find all the related files. And the general idea is that the features, they should never be able to import anything from each other. You have a shared layer, and this shared layer are your base components, like, I don't know, base button, also some composables, which are fine. And then you have the problem that sometimes you have a page that is using 2 or 3 different features. What you then do is that the page component itself is then just importing the features. So most important rule, features should never import anything from each other. They need to decouple. And as we also learned today more about model generation and micro-frontends, once you have the setup, it's also easy to go to the micro-frontend approach because it's already split up in a way to do that. So the 3 things I think every project should do if you want to get more out of AI is setting up a context. So agents, MD, skills, hooks, brain. You don't need to do it exactly like the brain maxing approach, but I think there are many interesting things that this repository is doing. Then also we need to have many different feedback loops. The more, the better. And also going with vertical slices. So where I think this is heading is, IFK coding is already here. What is IFK coding? The idea is IFK means away from keyboard, and we also have this human in the loop process. And what I think is, at the beginning, you have business people and developers. They think, what do you want to build? Developers or architects, they think also about the big questions, which database we should use, everything. But once the spec is clear, you can have a workflow. I wrote more about it on my latest blog post, but you have a workflow that is in the end doing something what a real developer, a good developer would do. Like you have a big ticket, you create sub-tickets out of that, then after you implemented something, you have a refactor step, you also have a QA step, and then you get a PR, and then developer has to read the code. And then if something is not working good, then you also try to improve the setup with ESLint and AgentsMD, but I think this is how a good workflow is at the moment. So if the agent did something wrong, don't change the way you prompt, change your factory. Try to create a custom ESLint rule. If you have a code base that has messy code, use the agent first to refactor the code base. Otherwise, it will not work. And I don't know who of you knows what React Inc. is. Ever heard about it? So the idea is that with React components, you can declare UI for a terminal. And last week, I tried to use AI only to do a React import, and it worked, really good. You see here, I don't know what is an interesting example. The snake one, So this is running in the browser, but it's using something also that which VS Code is using for the terminal to emulate in the browser how a terminal would work. And then, And this is all just Vue code. So this is the library, Vue Inc., use input, use app. So it's a port from React Inc. Everything was created with AI last week. And how did I create it? My idea was, you also use the techniques of the brain, but React Inc. has many tests. So what I did is I ported the tests first. And then once I had the tests, then I said to the agent, now do the Vue import. And this was working quite well. Now I don't want to make an official library out of that because I think now I would have to start again and take more time and really understand every line of code. Otherwise, I would not publish that. But I just wanted to try it out if it's now possible to use a React library if they have many tests, and then to use AI and to make a port out of that. And this works. Also, one interesting thing that I added is also a hook that is running in the background, and then it's automatically updating the brain. So this is the hook. Once the session is done, there's a prompt, read the session transcript, and only update durable learnings. And this also works kind of good. So you can use Cloud P, and then this is running under the background. So you have a workflow where every time you give a task to an agent, your documentation will also be automatically updated. And yeah, this talk, I think, was not really about AI. I tricked you. This was, in general, about best practices for building software. And yeah, everything that we learned about functions should not have too many parameters. Tests are good. All these things that we know, now they are important. And the good thing is, if you have a bit of understanding about these things, you can also use AI to add tests. And yeah, thank you. I think we have